Welcome back to Learning with us here at MPB. I am Miss Killen. I'm so glad you came back. We are still in Unit 5, looking at that linear equation, inequalities and function. We're in Lesson 6 today, which is Introduction to the System of Equations. We're looking at REI 6 and 10. I can solve linear equations using different methods. All right, so our system of equations, you may be sitting there and you know what a system is. You know what equations are, but how do we have a system of equations? That's a good question for us to have. System of equations are where two or more equations, and each of the equations are on the line. So when I have a system, I have multiple lines that are graphed, and they may intersect or they may not intersect, but they're all connected some way. So let's look. I have line A and I have line B. Line A is y equals 4x minus 4. Line B is y equals 10x plus 2. In this system, where these two lines intersect is going to be called its solution. That means where both of these equations are equal. So in my blue equation, at -1, it equals 8. In my red equation, where it's -1, it's going to equal 8. So if I plugged in -1 for x and 8 for y, I would get the exact same thing for both of these equations. They would completely equal. And that's what our system of equations is. Now, I need to remember, any ordered pair that makes an equation a true statement is a solution. Therefore, if a system of equations intersect, that ordered pair makes both equations true. If a system is parallel, does not cross, there is no system, or there's no solution in this system. So let's see what those are going to look like exactly. It says y equals 4x minus 4 and y equals tx plus 2. Look at these two equations again. If we graph them, they intersect at -1, -8, which both the x and the y values make the equation true. So let's plug these in. All right, so here is my calculator. So everybody is going to pull up their calculator, and we're going to put our first equation in, which is 4x minus 4 for y1. y2, we're going to put 10x plus 2. Now, if I graph them, yes, I will see where they intersect at that -1, -8. But what I really want to look at is my table feature. Now, does everybody remember how we get our table feature? Good job. Second graph. Now, I know when I looked at my graph that I'm going to -1. Now, do we see at -1, y1 is -8 and y2 is -8. That is where both of my equations equal. So at -1, -8 is where both of my equations are equal. It says consider this system of equations. 5x plus y equals 10 and y minus 10 equals 3x. So here's my system. Make sure both equations are in slope-intercept form so we can put them in our calculator. Or if we're just using Desmos, Desmos will take them just like this. But just so we can get some practice, let's go ahead and put them into our slope-intercept y equals mx plus b form, just so we can get some more practice on that. So the first one I'm going to do in red. So let's go here. So I have 5x plus y equals 10. I'm wanting to get y equals mx plus b. So I'm going to subtract 5x on both sides. Y equals a -5x plus 10. So we've got that first one. Now let's look at the second one, and I'm going to do it in purple. So I've got y minus 10 equals 3x. I want to get that y by itself. So I'm going to add 10 to both sides. So y equals 3x plus 10. Now what I want to do, since I've got both of them in y equals mx plus b form, let's first look at our calculator. Everybody pull your calculator up, like we've done. We're going to go to y equals, and we're going to plug in negative 5x plus 10 for y1. Then we're going to plug in 3x plus 10 for y2 and see where they intersect. Exactly right. They are intersecting at 0, 10. Now, let's pull up that Desmos calculator and let's see how that works. So I'm pulling up my Desmos and I'm going to put my system in there. I'm going to put it in the way it was given to us. 5x plus y equals 10. There's my line. My next one, I'm going to put y minus 10 equals 3x. Now, I can't see my intersection. I'm going to pull down my graph. All right, so here's my graph. This is where it is intersecting. And if I hover my mouse over my point, it shows me 0, 10 as my intersecting point. So we've got two different ways to see that solution set or where those two lines intersect. All right, let's look back. It says, consider this system of equations. Same system, but now I have a question of, using the same equations, is there any information about 731 and 20? So let's go back to our Desmos and look. So it tells us to use this same equation system, and it wants to know about 731. So I come over and look at 7 and go up to 31, and what do I notice? At 731, which is right here, right there, I am only using y minus 10 equals 3x. So it is only on that one graph. The next one, it asks us about 20. So I need to go back down here and look at 20. So at 20, I'm only on my 5x plus y equals 10 graph. So both of those points are only on one graph. Now that second question asks us about negative 5, 2. So I'm going to go over to negative 5 and up 2, which is about right here. And it's not hitting either one of my graphs. So it would not be any type of solution or any type of number for anything that would deal with this system. So I would say it lies on neither equation. Good job. Let's do some practice. So look at these two lines. I have t, that is 3x plus 9y equals 18. I have p, which is 4x minus 20y equals 24. And so here are some questions that I'm dealing with this system. Does the system have a solution? If so, what is the coordinates? If not, why? So what we can do is let's plug this into Desmos. That would be the easiest way. So let's put this in Desmos and see what we come up with. So I'm first going to put in my t line, which is 3x plus 9y equals 18. Then I'm going to put in my p line, which is 4x minus 20y equals 24. So I can see right away where these two intersect. I hover my mouse over and it intersects at 6, 0. So when I come back to my notes page, I'm going to put 6, 0 as my solution. That's the coordinates. Now number 2 asks me, is 4, 2 a solution? So let's go back and look. Is 4, 2 a solution? So I've got 4, 2, which would be about right there. Well, it's not touching anything. Here's 4, 2, and there's both of our lines. So I would have to say that it's on neither one of those lines. Neither one. So number 3 says, consider 3, 1. Is it a solution? So let's go back to 3, 1 on our graph. And I've got 3, 1. It's going to be about right here. And it is on neither one of those. Let's see, 3, 1. Nope, it is. It's on our 3x plus 9y equals 18. That's very important that we make sure that we hover over these points to see which line it's going to be on. That was a good learning lesson for us. So it is going to be on line T. So now we have seen different points in this system, how they lie, if they're on both lines, if they're on one line, or if they're not on any lines. So let's see what else we've got. What do we say about 2 lines if they do not have a solution? What have we said if my lines do not have a solution? That's right, they don't intersect. And what have we heard or what have we learned about lines that do not intersect? Exactly right. They're parallel lines. They never intersect. And so we would say the lines are parallel. And this is my example of my symbol for parallel. This is my parallel symbol right here. That's my parallel symbol. Good job. Use the following equations to sketch the system of equations. I've got negative 4x plus y equals negative 10. Y minus 8 equals negative 2x. Does this system have a solution? Sketch on the graph. Well, since we're using this graph, what I need to do is get them into our form, y equals mx plus b. So you work on your paper as I work up here, and let's see what we get. So I'm going to do this first one, and I've got positive 4x on both sides. So I'll have y equals 4x minus 10. And then my second one, I am going to add 8 on both sides. So I would have y equals negative 2x plus 8. So now that we've got both of them in our slope-intercept form, I'm going to draw my graph, and then I'm going to plot both equations. So let's do this. So we're going to have our y-axis here, and we're going to have our x-axis here. So I'm going to have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then I'm going to 2, 4, 6, 8, 10, 12, 14, just so I make sure I have my numbers. So let's graph the red equation first. I know that it crosses my y-axis at negative 10. So let's go down here and just make this equal negative 10. So I'm going to put my dot right there at negative 10. And then I'm going to go up 4 over 1. So I've got 2, 4, 6, 8, 10. So I've got 2, 4, 6, 8, 10, up 4 over 1, up 4 over 1, up 4, 1, 2, 3, 4, over 1. And that is a good example of my red equation. Now let's look at my green equation. Y'all make sure that I have put my numbers right, because Miss Killen does make mistakes as well. So for my green equation, it says that I am crossing my y-axis at positive 8, so it's right here. And it says I'm going down 2 and over 1. So I'm going to go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. So here is a good example of my green equation. Now, we want to see that this is where they intersect. Now, this is just me drawing, so it's not exactly on the line, but it is a good representation of where those two would cross. If we needed an exact where they cross, Desmos in our calculator is a wonderful place to look. Speaking of, here comes Desmos. So let's put these in our Desmos calculator. I've got negative 4x plus y equals a negative 10. And always make sure that you plug in the correct equation. We see how I had put an extra variable in there. And then let's put our y minus 8 equals negative 2x. So I am looking at 3, 2. So when I go back, it's roughly 3, 2. It's a little off because we got to take in consideration I can't draw a perfect straight line, but we see that we are looking at 3, 2. That is a very good way for us to check our work. If we're on a test or we're on an assignment and they want us to show our work, we can show our work. Then we can always go and use the calculator or Desmos to make sure that we're doing right and checking our work. We've always got those extra tools in our toolbox to help. So now it's time for us to master. I want to consider the system of equations. 3x plus y equals negative 1. 3y plus 3 equals 4x. I want to sketch this system on the graph. I'm answering, does this system have a solution? And what is the coordinates if there is a solution? So go ahead and pause the video and work with your table partner or by yourself on your notes page, and then come back to me and let's see what we've got. All right, so we're back. We're going to throw this on our Desmos to see if what we've got matches what you did in your notes page. So let's go ahead and plug it in. If I would have gotten this in our slope-intercept, it would have been y equals negative 3x minus 1 for the first. Then I would have had y equals, I would have had a fraction of 4 divided by 3, x minus 1. Another example of making sure that we arrow over and we put the correct equation in. All right, so now that we've got the equations put in correctly, I see that my solution is at 0, negative 1. So when we go back to our question, it says sketch. So at 0, negative 1 is about where my two lines would intersect. And it says, does it have a solution? Obviously, it's at 0, negative 1. And then it says, what's the coordinates? 0, negative 1. Making sure that it looks similar to what it did on Desmos, because sometimes they're going to ask you which picture is the correct intersection. So you're going to need to be able to go from Desmos or calculator to a picture of it. So you want to make sure that it is intersecting at 0, negative 1. Good job. Let's look at our next one. If two functions are on the same coordinate plane, yet there is not a point of intersection, they are considered parallel lines. Which of the following would be considered parallel lines? Now, the best way to do this, the best way is to pull that Desmos. So let's go ahead and put all of our sets in there. So first I'm going to put my first answer choice, which is y plus x equals 3 and y equals 2x plus 1. And it says, are they parallel? No, these are not parallel. These actually intersect. So it says, which one of the following would be considered parallel? So I know the first one is not my answer choice. So let's go to the next answer choice. And I've got y equals 2x plus 3. And I've got negative 2x plus y equals a negative 6. So let's see. Do these intersect? I don't see where they would intersect. Do you? Nope. So then I know this is not my answer. Which would be considered parallel? I know this one would be considered parallel. So let's check out the rest of them. Let's see if the rest of them would show me. Let's try answer choice number 3. So I've got 4x plus 2 equals y. And then I have y equals negative 2x minus 1. At negative 1, 0, these two intersect, so I could not say that they are parallel. So this is not an answer. Let's try that last one. So I've got 8x equals negative y plus 1. Then I have negative 1 plus 8x equals y. And I see that those have an intersection. So when it asks me in my problem which one is considered parallel, B is my only choice for parallel lines because there was no intersection whatsoever. Good job. I do not want to forget, ordered pairs that make an equation a true statement for all equations in that system is considered its solution or that solution set. Parallel lines do not have a solution because they never ever cross. Thank you for coming to learn here with us at MPB. I'm so happy that we're doing this together and I'm looking so much into digging into this chapter 5. Thank you. I'm Miss Killen.